Hello everyone and welcome to the tutorial on logistic regression implementation in Python by ThinkUponAI. So today we would be going step by step implementing all the methods that we need in order to train and test the logistic regression model in Python. And further, we would also see how we could improve the performance of our model using some basic tips and tricks. But before we proceed, I'd like you all to know that the main focus of this tutorial is to familiarize ourselves with the methods available in the Python libraries and not on handling the complex data sets. And that is why we also haven't considered any complex data sets to keep it as simple and as short as possible. Now, without wasting any time, let's jump into the notebook. Okay, so let's start with the notebook. Okay, to begin with, the dataset that we have considered for our classification task is a wine quality sample dataset taken from the northern region of the Portugal. These wines are also known as vineyard wines. Now, the link for our dataset is provided in the notebook. Also, I'll provide the link in the description of the video down below. Now, once you open the link, you'll see the wine quality dataset, and it includes two datasets, one for the red and one for the white variants. But for simplification, we would only take the red variant of the samples. Also, the main goal of this dataset is to classify the wine samples in good or bad quality wines based on some physicochemical parameters that are being available to us in the dataset. Now, to download the dataset, you can use the right hand side download button and it will download your dataset. Once the dataset is downloaded, you can just open the folder, extract the folder, and as you see, the folder contains two files, one for the red and one for the white variant of the wine. But as we have already said, we would only take the red variant and we would copy this into our folder containing the notebook. Now I can show you the notebook that I have already contains the .csv file for the red variant. Now, once we have stored the dataset, we can start importing the required libraries for our case. So we have imported the NumPy library, which is the basic library required for any linear algebraic operations. We have pandas, which helps us store the dataset in data frames and further process the dataset. Then we have cbound library. It helps us better visualize our dataset. Then we have the logistic regression model imported from the sklearn.linear model library. So we can run this cell to import the required libraries. So this star shows the cell is in process. So as we wait, the libraries are being imported to our environment. So yeah, so it's done now. Now we can move forward to our next section, which is loading the dataset. So in order to load a CSV file, we can use a .read CSV command from the pandas library to store the whole dataset in a variable called wine. Now the good part about the pandas libraries is that it has different built-in methods available which can be used in order to visualize the content in many different ways. So here I have mentioned few of them which will help us visualize the dataset. To start, we can use a .head command. Let's see what it shows. So it shows us the initial 5 entries for our dataset with the column and row labels. So we can see all the parameters for our wine data. We have the acidity parameters, we have the chlorides, we have the sulfur dioxide content, the density, the pH, and the alcohol content. At the end, we also have a quality column which helps us know the quality of the wine. Then we can use a .info command, which is also from pandas library. So it shows us the number of entries that we have. So we have 1599 entries for our data set and all of them being non-null. So if there is any null entries, we have to handle that particular row in order to further train the model. Also, we can see the type of data set that we have. So most of our data set is in float type. And the last column, which is the quality column, is stored in an integer value. Then another command that we have is .column name. So here, if you want to see a particular values from a particular column, we can type that column name in order to see the value. So for example, we have the quality column at the end. We can just type in the name dot quality to see the values that it contains. So it contains all the values 5, 6, and it could have more, but we can't see all of them at once. One more thing is the another way to see the values for a particular column. Let's say we want to see the values of fixed acidity column. By this method, if I just type fixed space acidity, it will give me an error because it will not consider space as any character. So in those cases, we can use these square bracket along with the inverted commas to print our values. So this is just an alternate way of printing the values for any specific column in the data frames. Now, another command we have is a dot describe command, which I found most of the times helpful. So what it does is it gives me statistical values for each of the columns in my data set. So it will give me the count, the mean, the standard deviation, the minimum and the maximum values, and the in between Q1, Q2, Q3 percentiles. Now, as we know that for our case, we would be solving a classification problem. So for that, we need some predefined classes. Now there are two things that we can do. One is for each quality value, which is varying from 3 to maximum of 8. And these are all integer values, remember. So we have in total 5 different values of quality for all the wine samples. So either we can consider all these 5 qualities and classify them into 5 different classes, or we can threshold these values and convert our problem into a binary classification problem where the values above a certain threshold would be considered good and below that threshold would be considered bad. So we would go for the second case. So what we have done is we have selected a threshold of 7. So all the values of quality which are greater than or equal to 7 would be considered as good quality wines, and otherwise it would be a bad quality wine. Now we can just run this cell, and we have also run a dot sample command which will take 10 random samples from our data set where we can see if it has taken effect or not. So you can see the last column, which is the good quality column, is added based on the thresholding that we have done. So for the quality of 6, it is classified as 0, and for the quality of 7 or above, it is converted to 1. So the good quality column contains only 0 or 1. So now we have converted our problem into a binary classification problem. Now, in order to visualize the correlation between our data set, we can use the pair plot command from our Seaborn library. So what it does is, on both x and y axis, it takes the columns that we have in our data set and plot the points in order to see the correlation between the different columns. So it takes a little bit of time, but I'll explain. Here I have used two dot pair plot commands. So just to explain you the difference, the first command is without the parameter of hue. So what this command does is it plot the points based on the good quality column. So if a wine has a bad quality or a good quality, that means if the wine has 1 in the good quality column or 0, it would color that point based on these values. So in a few seconds you'll understand what these values show up. Okay, so I'll wait.
One eternity later.
Okay, so now we have our output, and now I think it's not visible. If I zoom it a little bit, you can see that there is the fixed acidity and the volatile acidity, all the columns projected on the y-axis, and on the x-axis the same columns are being plotted, right? So if you just see the first figure, so the first figure shows the fixed acidity versus fixed acidity plot. So basically what it shows is the histogram for the fixed acidity column. So for the next part, if you see the fixed acidity versus the volatile acidity. So on the x-axis we have the volatile acidity. On the y-axis, we have fixed acidity as our parameter. And you can see all the points which are plotted accordingly. Now, what you can see with these plots is, let's say this plot. Consider this plot. So you can see as the value of the y-axis increases, the x value also increases. Oops. Yeah, sorry. So as the value of the y-axis increases, the x value also increases. So with this particular figure, you can see these values are particularly correlated in a positive direction. And the next figure shows the negative correlation. Now, if we see what these values are, we can see that these are the density and the pH values. So with the increase in the acidity, you can see the density value of the wine increases, which is interesting to note. And with the increase in the acidity, the pH value decreases, which we have studied in our high schools as well. So these type of figures help us to visualize the correlation between the data set. And for the second part that I was saying, when I have passed the hue command with the good quality as column, you will see we have two different colored points. So the green ones are the points with the good quality wines and the red ones are with the bad quality wines. So you can see in every plot where the good and bad quality wines lie. And for example, if you take any figure like this one, so this figure contains the good quality wines more towards the right and the upper part of the region, while the lower and the left part are the bad quality wines. So with these kind of analysis, you can just get some more idea about the data set that you have, and it will help you further improve the performance of your model in future. So moving on to the next part, if you want to just plot the histograms for any particular data column, then you can use .hist command from the pandas library. And here I have also given the bins parameter, which as usual decides the number of bins that we need for our histogram plot. So the more the number of bins, the more fine is our histogram, and the less number of the bins, the more coarse would be our histogram. So you can see these are the histogram plots for each of the columns that we have. Now, what you can observe with this, let's say this chlorides histogram. So you can see the chlorides value of close to 0.09 have the maximum wine samples. So it's more than 850 or yeah, something around that. But for values after zero point 0.3, we have very few samples in our data set. Now, what it shows is that there could be some outliers in our data set which could affect the model accuracy as well. So these outliers are needed to be removed in order to further improve the accuracy of our model. So you can see something similar pattern in the residual sugar as well. Also, just on a side note, you can see the quality column and the good quality column. So the good quality column has the samples with only 1 and 0 values, but you can observe the number of values that we have in bad quality wines are much higher than the good quality wines. So our data set is also unbalanced. So we don't have equal number of samples for each of the class, and that also deteriorates the accuracy of our model. Further, there is one more function from pandas library that helps us analyze the data by aggregating them according to their mean values. So here I'll run this .groupby command. So what it will do is, according to the quality of the wine, it will take the mean of all the columns that the dataset contains, so that we can see what is the average value of a bad or a good quality wine contains. So let's say if we compare for good and bad quality, let's say if we compare the sulfur dioxide content. So the sulfur dioxide content in bad quality wines are higher, as we see, as compared to good quality wines. So that's one observation that we can have. Another observation that we see is the alcohol content naturally is higher in the good quality wines. Okay, moving on. Once we have processed our data set, we can start preparing our dataset in order to train and test the model. So to start, I have created a copy of our dataset and stored it in X and Y variables, where Y contains the output column, which is the good quality column, while X contains all the other columns that contain the input parameters. So once this is copied, then we can again see how many values does our Y variable contains. So as we have already observed before, the number of bad quality wines are much higher as compared to the good quality wines, and that's an indication to an unbalanced class numbers. Moving on, we have used train test split method in order to split our dataset into training and test dataset. Now in this case, we have considered a test size of 0.3, which means 30% of our dataset will be used for testing purposes and rest of the 70% would be used for training the model. So once we create our training and test dataset, we are ready to move on with our model. So in order to train the model, first of all, we have to create an instance of our logistic regression model. So we have done that here, and then we have used dot fit method in order to train our model on the training dataset. Now once the model is trained, we can simply use dot predict command on our test dataset in order to predict the output values. It is as simple as that in Python. Now once we have our trained model with us, we can use different performance metrics in order to check the performance of our model. These performance metrics include precision, recall, F1 score, and accuracy. And today we would be using accuracy as our performance metrics. So if we see the results, our model has achieved an accuracy of 87.91% on the test dataset. But does that mean our model is good enough? We don't know yet. So in order to gain more insights into the results, we can use confusion matrix in order to see how many of the points that are predicted by our model are correct or are wrong. So we can plot a confusion matrix from sklearn library here. So it is plotted here, and as you can see on the y-axis, it contains the actual label, which are the true values of the good quality column. So 1 represents a good quality wine and 0 represents a bad quality wine. While on the x-axis, the predicted label are being plotted, which are predicted by the trained model. So if we see the true negatives that we have, that means all the bad quality wines which are correctly predicted are 403, and all the good quality wines which are correctly predicted is just 19, and the good quality wines which are wrongly predicted, that means which are predicted as bad, are 44, which is very much higher than the true positives. So this shows that our model is still not good enough and we need further improvements in order to improve the accuracy or performance of our model. So that's it for today, and in the second part of the video I would be discussing some tips and tricks in order to achieve better performance for our model. If you find any part of this video helpful, please hit the like button and subscribe so that you don't miss the second part of the video as soon as I upload it. Thank you for watching.